So I'm going to talk to you in the next 20 minutes about work that we're doing in the domain of hardware failure prediction. And of course, inside, this is an internal work inside Dell-EMC. So what I'm plan to cover, if time will permit, is to tell you just in a few words about the company and our team, which has a pretty unique working model in the data science landscape, I think. And then we will talk a bit about motivation and the state of hardware failure prediction in general. I will then walk you through a sample use case of hardware failure prediction, which is a project that we're working on in the last 2 years or so. It started as an internal project, turned into a research project. I will explain why, and it is still in progress. I will conclude with some key takeaways, not only about the domain and the problem, but more generally about data science in a big enterprise environment. So a few numbers on Dell, which I believe you may have, that the name Dell is pretty much famous, but Dell is only part of this new company called Dell Technologies. And those those numbers, tells the story of Dell and the EMC after the merger. What's important for this talk is to understand that although Dell is known mainly for its consumer market and personal laptops, it also offers much of what we call a mid-range storage. And EMC is originally a company that turns into enterprise customers for storage, servers, and backup systems. And this means that we now have a very huge install base, millions of systems and hundreds of millions of drives installed. This is only on the enterprise. I am not going to talk today about the consumer market, which is also big. And this means, of course, a lot of data that is being collected and sent home from those systems. So a few words about our team. As our name suggests, we're a service team. It is not so typical in an enterprise environment, at least, and data science in particular. And another thing that I believe is unique in our setting is that our organization, from an organizational perspective, we are part of the IT. And IT is many times captured as the less innovative, more of the, the guys that are doing all the hard and black work behind the scenes. But it actually hides some very nice advantages for data science team, as IT also, is the closest one to the data. So instead of begging to IT to, help us to acquire the data, we are actually part of it. So from one side, it means that we have no one to complain to. On the other side, it really eases teams, and it has some very nice advantages. We are providing data science services not only in the hardware domain, but also in all other use cases, both for internal solutions inside the enterprise and to external customers as part of solution packages. So if you're buying from Dell a storage system or even a workstation with some GPUs from NVIDIA or in partnership with Intel or something like that for deep learning or for advanced data science, then some mid-range companies will prefer to buy also consulting services from us, and then we're providing the data science part of the solution. Okay, so enough talking about us and some words about the domain. So mainly motivation. It's very important for me that you will understand why hardware failure prediction or predictive maintenance in general has become such a centric centric domain and a very important and gain lots of interest in general in the industry. And the right and the left reasons, I think, are the most important one, right? So many support organizations, not only in our organization, I think across the whole industry, are going to the proactive, innovative support model. It means that before the malfunction happens, before the drive will fail, before the system will collapse, before the data will be lost, we will call the customer and we'll tell him, hey, we have a model here that alerts that in very high probability your system is going to collapse in a week or so. So we are sending a technician tomorrow to replace the suspected drive. And by that, we are on one side preventing, the very big no-nos of the storage company, of data in general, but as a storage company, of course, this is our biggest concerns, that the customer will suffer from data loss or data unavailability. And of course, we also improves the confidence of the customer and the whole customer experience. A third reason, which is also very, very important and a nice feature or added value, is that we're preventing over-provisioning. It means that many times, companies are buying systems that they are really an overkill for their needs. And by analyzing and monitoring their use patterns, we are able now to, making a personalization based offering for the customer. So the system will suit his needs. He will pay much less money, and of course, once again, will be hopefully happier with what he gets. So there are many good questions in this domain, much more than we can talk about today. Some of the questions that we are facing is, which drives on the data center of this customer are going to wear out in the next 6 months? So we are developing forecasting, time series forecasting, much like the previous speaker, found a lot of correlations to the economical models. Time series based forecasting to monitor the wear and tear of a drive and additional hardware parts. The one that we will talk in more detail soon is whether your specific drive or specific server, whether it's flash or spinning drive, will fail in the next, say, 14 days or 21 days or whatever is your need. Can I offer you to use a drive that is much less expensive, but its quality is more suitable for you, say, 0.5 writes per day for those who are a bit familiar with the industry? Then for many of those customers, this solution will be very good, but today, you will find out that many are buying 10 writes per day drives, which are much less expensive. And in the use pattern of this specific customer, it will take, I don't know, some of the models gives us, 1,000 years until they will wear and tear finally, at least by the use by the way they are being used today. And it allows us to answer more complex questions like how probable is a data loss event for this specific customer. Okay, so I won't get into too much technical details. I will give you some references for those, and you're, of course, welcome to talk to me or contact me for more details, but I will try to give an overview of a specific use case around hard drive failure prediction. And let's start with how this whole thing started around 2 years ago. We were approached by many business units in Dell-EMC that suggested the need in developing such predictive modeling. And when we started to look around and see what was done in the industry, what was done in academia around these issues, so there were quite a few works around this, but most of them, the majority of them, focused on a population-based approach. It means that there were very good models that predicted that if the drive is, say, 5-year-old, then it has an average failure rate of, I don't know, or mean time to failure for a specific vendor or a specific model. But there were very few works that tried to take a look at this in the single drive level and predict whether this specific drive will fail. And the sum of the academic work that was done there, we find it to be less suitable or very hard to take it from the theoretical level to an application. Then we kind of had to, although we relied on some of those ideas, we kind of had to begin a research and development process from scratch. And the target was very clear. We want to develop a classification model that can give us an alert based on the business needs ahead of time whether the specific drive will fail or not. And again, the why question, so we had all those motivations that I talked about earlier, but specifically, we wanted, of course, to save money, and we wanted to improve the customer experience. So other than the reasons that I mentioned, improved logistics is another very important point. It turns out that one of the pain points for the support engineers, for the support organizations in an enterprise environment, the most expensive is, a very significant expense is to send a support engineer or a technician to the customer site. And when I predict that some of his drives will fail, I can reduce the number of required visits, and by that, I can save lots of money to the company. And of course, a customer sees an innovative approach, an innovative support strategy, and hopefully they are happy, and we are happy as well. Okay, so a few words about the data. And the data in this domain is very, based on some attributes that are collected from the drives, the drives itself. And they tend to vary a bit about different vendors, but basically there is a protocol named SMART that was adopted by the industry in the 90s. And it is a set of standard counters that measure all kinds of features around the drive. In addition to those, we used features that were collected on the specific customer or on the specific system, like the vertical of the business, of the data center. It turns out that there are major differences in the way storage systems are being used in different verticals. And information about the system itself, like the age of the system, the date, the installation date of the drive, the vendor, the model, and so on. And we were not surprised, of course, to find out that even internally, inside a huge enterprise like Dell or EMC, we find out that, each business unit, and there are few products that are developed by Dell and offered, and each of them turned out to collect the data in different formats, on different frequencies, different protocols to collect the data, and so on. And of course, it made our life harder. And as always, we had all the typical issues of data, and we had to deal with sparse tables, missing data, corrupted logs, and so on. So one of the most challenging parts of this effort, like many other projects with data that is relevant across the organization, is to do data consolidation. We had to take data from many different resources in the company, each in a different format, some structured, some unstructured, starting from the customer experience unit, the global drive engineering unit, each of the business unit We had to first unify those into some standard way and to do feature engineering on a very, in a very unified data set, and it was really challenging part that took a lot of time, and at the end we managed to create a reasonable data set that was put in the business data lake, which is modeled to, like a centralized data set that hold information and can be approached by analytics and data scientists from all around the organization. So this is the basic model that we built. We took all kinds of data and features, fed it into a random forest classifier, after some model selection process. It was not a surprise. There was nothing really fancy in the model itself. And after some optimization, we managed to create a classification model that gave us the fail pass alert as we wanted to. It was very important for us from the beginning to work closely with the business, with the customers. I mean, the customers are the business units in this case, and to give them a dashboard that will allow us together to get a decision on some very subtle points. And one of the most important ones was to decide what will be the threshold, the confident threshold of the model that will give us the confidence to say this drive needs to be replaced. Because false alarm in this case are very, very expensive. To send a technician to replace a healthy drive is expensive for the company, expensive for the support organization. It is not a good experience for the customer, of course, and creates lots of troubles. And each, say, 0.1 or even 0.01 in this confidence threshold to put the drive and decide that if we're confident more than, say, 0.7, it is enough to say that we are going to replace the drive is not easy at all. So this is just a point to clarify that sometimes you need more than the model to gain the good relationship with your customers on data work. So time is short. I will just say that results were disappointing, and don't worry, there is a good end to this story. And the data was bad, and that was not a problem for us, the data scientists, because we can just say it's not our blame, yeah, right? Just collect the good data. But since we knew we are working in this company and we wanted to stay on the company, we had to come up with a solution. And we went into a very interesting strategy, I think, which is much more general than this domain. And this is research. What we did is to go and look for good data outside. And the reason is not that we can utilize this data to develop a model that we can use internally, because there are many differences. But we could have convinced our executive that it's worth spending some time and money on new and improved collection protocols. Then we went out and luckily found Backblaze. Backblaze is an online cloud storage company that releases every quarter some very high quality data from their 50,000 hard drives on their data centers with very stable frequencies, very good collection measures. And we started to analyze this data. We found out that in addition to all the standard attributes, it is very helpful and meaningful to extract some time series-based features. So we created a linear function or a linear regression on those samples and started to collect on different time windows all kinds of time series-based features. This really helped the model. So I won't get into the to the technical details. Once again, you can refer to those on the deck itself. It is much like the time series model that was presented here before, but basically we divided the data not to training and train based on the samples, but based on time. We took some random date or the failure, or we did it with respect to a failure date, and we managed to simulate successfully a production environment. We did some very extensive feature engineering, fine-tuning on the right windows to take those time series features, and eventually came out with a better model. So the initial results were not too impressive, but yet very much better than what we had before. A recall of 26% means that we were able to predict 26% of those failed drives to fail. Yeah, I understand the music. Okay. Yeah, so let me wrap up just by saying that later those was improved, and this is still a work in progress. We are talking about much better numbers now after lots of data work, and I want to really wrap up with some key takeaways that are more general than that. Can you, yeah, let's go forward, a bit forward, yeah. Okay, so some key takeaways from all this talk, and what I want you to take home with you is that data science are many times the educators for the value of data. This is not an arrogant thing to say. This is just saying that executives doesn't always understand the real value of data collection protocols and quality data. It needs to be clear that data science is a must-have for big companies and not just a nice-to-have features. POCs over open data are a very good idea to showcase potential to executives, and always provide a rough estimation of your model's dollar value, because at the end, this is what important. One last word is that it's not a bad idea to have data science in your IT organization. They are close to the data. They can do things much faster, and don't be surprised that you can pose a threat sometimes to the traditional corporate analytics roles. Thank you very much for listening, and sorry for the little delay.